Hello and welcome back to another fun-filled edition of Geometry. We are in Chapter 2, Section 4, Algebraic Reasoning. Okay, we're going to look at a few properties that you should already know. The addition property of equality, which means if something equals something, if you have an equation, you can add the same thing on each side of the equation and it's still equal. Okay, subtraction property of equality, you can subtract the same amount on each side of an equation with the equation still being true. Multiplication property means you can multiply by the same amount on each side as long as you're not multiplying by 0 and the equation is still true. Division property, same thing, you can divide on each side by the same number as long as you're not dividing by 0 and the equation is still true. And the substitution property of equality says that if A equals B, then I can substitute A in for B wherever B is used. Okay, so if A equals 3, then if I have 2A, I can substitute 3 in for A because I know that A equals is the same as that. All right. Now, justifying your steps. This is our first step that we're taking towards proofs. Okay, we want to solve this, but as we're solving this, we basically want to say what we're doing in each step. Why are we allowed to do that? Okay, the first thing you'll always start with is you're going to write out the equation as you have it, or whatever statement was given, and then you say that that was given. Okay, that's the first thing you do. That's the easiest part of this. So our equation is 3x plus 2. It's equals 23 minus 4x. All right, our next step here, we will move the variables to one side. So I'm going to add 4x to each side in order to eliminate it here. I can do that because of the addition property of equality. I can add the same amount on each side. So that's my reason. What am I doing? I'm adding the same thing to each side. Why can I do that? Because of the addition property of equality. Then I simplify here. 3x plus 4x is 7x. Next, I want to get the variable term by itself. So I'm going to subtract 2 from each side. I can do that because of the subtraction property. Then simplify again. Now last step, I'm going to divide by 7 on each side. That's the division property of equality. Okay, so this is what it looks like justifying the steps, saying what am I doing in each step. The distributive property you should be familiar with means we take what's on the outside of the parentheses and we multiply with everything inside the parentheses. So A times B plus A times C. Same thing works for subtraction. That would be A times B minus A times C. All right. We need to justify each step here. So we're going to solve and justify each step. All right, so we are given negative 5 times 7w plus 8 equals 30. So negative 5 times 7w is negative 35w. Negative 5 times positive 8 is negative 40 equals 30. Okay, that is the distributive property. Distributive property. Okay, next, we want to get the variable term by itself, so we're going to add 40 to each side. Plus 40. So now I get negative 35w is equal to 70. I just used the addition property of equality. All right, now I'm going to divide by negative 35 on each side. And that gives me w is equal to negative 2. And what did I do here? I divided, so I used the division property of equality. And there you have it. All right, now there's a few more properties of equality that you might not be familiar with. We've used them a lot, but you don't know that this is what they're called. The reflexive property basically means that something is equal to itself, like a mirror here, reflected across there. So if we're talking about segment lengths, then we have AB is equal to itself, AB. Or in angle measures, measure of angle A is equal to itself, measure of angle A. Symmetric property, symmetric is when we flip it around. So A equals B, then B equals A. I can look at this. If AB equals CD for segment lengths, then CD equals AB, and angle measures works the same way. Just flip them around. Transitive property, this is kind of like the law of syllogism. So if A is B and B is C, then A is also equal to C. Right? So works kind of like the law of syllogism, called the transitive property. Works also for segment lengths and angle measures. So if A is B and B is C, then the measure of A is equal to the measure of C. All right, let's use this. We reflect a beam of a spotlight off a mirror lying flat on a stage as shown. Determine whether measure of angle DBA is equal to measure of angle EBC. So we want to know DBA, this measure here, whether that is equal to measure EBC. EBC, this one. Are these two angles the same? All right. So always start out with what you know. The equation, this is what we're given. Okay. I know that measure of angle 1 is equal to measure of angle 3. Now think through this. If this is the same as this one, and I add these two together, and I add these two together, this one and this one added together is going to be the same as this one and this one, right? So in order to get DBA, measure of angle DBA is the measure of angle 2, measure of angle 2, plus measure of angle 3. That's the angle addition postulate. Angle addition postulate. Okay, and we also know that measure 1 is equal to measure 3, so I can substitute measure 1 for measure 3. So I can say measure of angle DBA is also equal to measure of angle 2 plus measure of angle 1. I had to use substitution there. Substitution. Now, if I look at the other angle, measure of angle EBC, that is equal to measure of angle 2 plus measure of angle 1. Angle addition postulate. Angle addition postulate. Oh. Postulate. And notice that DBA is measure 2 plus measure 1, and EBC is measure of angle 2 plus measure of angle 1. So I can say that measure of angle DBA is equal to measure of angle EBC because of the transitive property. And there we go. That's what we wanted to determine. All right, here we have a park, we have a shoe store, here we have a street. On that street, we have a park, a shoe store, pizza shop, and a movie theater. In that order, the distance between the park and the shoe store is the same as the distance between the pizza shop and the movie theater. Show that the distance between the park and the pizza shop is the same as the distance between the shoe store and the movie theater. Okay, it's a little bit hard to keep track of all this, so it helps to make yourself a little model. All right, so let's say this is the street, and we were told that the distance between park and shoe store, and the park, that's the first two, park and shoe store. All right, so this distance right here, call that park, shoe store, is the same as the distance between the pizza shop and the movie theater. Movie theater is the last one. Okay, so this distance is the same as the distance between the movie theater. Okay, so approximate that here and here. I've already used P, I'll use Z for the pizza shop. Okay, we're told that this is the same as this, so we're going to indicate that like so. Say these two are congruent. Now, we want to show that the distance between the park and the pizza shop, this distance right here, is the same as this distance right here. All right, so let's get started. Move that up a little as a reference point. Okay, I'm going to write my equation over here and my reasons over there. Okay, so we'll start with what we know. We know that PS is equal to ZM. We were given that. Given. Okay, next we know that PS plus PZ plus SZ gives me PZ. So we know that PZ is equal to PS plus SZ. All right, and that is the segment addition postulate. All right, then we also know that this segment SM is equal to the sum of its parts. SZ plus ZM. Segment addition postulate. This is a good time for you to be practicing your Z's if you write them the wrong way around. Okay. Now my goal is to write a statement where I have these be equal. So here I have PS is equal to ZM, and here I have ZM plus SZ, so I can take this first statement, PS, and I can add to, well, let's finish writing this out, is equal to ZM, and I can add SZ to each side, plus SZ, plus SZ. All right, I can do that because of the addition property prop of equality. And now, notice that I have ZM plus SZ, which is this statement, PS plus SZ. So this equals this equals this. I could say that PZ is equal to SM. I can use substitution here. Substitute this in for right there, and substitute this in right there. Substitution. Substitution. Property. And there you have it, ladies and gentlemen. This is what you learned today. Check back for more lessons later.